Then we move on to applying cyclical encoding to time features. So df cyclical encode data call max value is equal to data.call plus sign is equal to np.sign 2 times npi data.call max value data call plus cosine np cosine 2 times np.pi times data call max value return data. Basically what this block of code does, it basically applies a cyclical encoding using like the sine and cosine transformations. Then we move on to df.clean. This is cyclical encode df.clean hour till 24 all the way to df.clean cyclical encode df.clean minute comma 60. Well, basically what this block of code does is it applies and cyclical encoding to like the hour, day of the week, and minute. Then we move on to cyclical columns equal to a call for a call in df.clean columns if sine and call or cosine and call print cyclical columns. Basically what this block of code does, it iterates through like all the columns in like the df.clean columns, and it basically filters out the columns that are either contain like sine or cosine in their names, and then afterwards it creates a new list called cyclical columns with only those that have like the filtered columns. Then afterwards we move on to displaying the sample of the cyclical features over here. So here like all the new columns created, hour, sine, all the way up to minute, cosine, and here's like the sample of the cyclical features over here from like hour to like day of the week, cosine. Then we move on to visualizing cyclical encoding by doing fig plt.figure fig size equal to 15 times 5 creates like a 15 by 5 dimension. Then we move on to basically plotting like the hour in cyclical coding over here. So subplot 1, 2, 3 creates the first subplot in the 1 by 3 grid. Hours is equal to range 24, basically creates like list for like 0 to all the way to 23 for like the 24 hours. And then we have hours equal to np.sign 2 times np.pi np.array hours divided by 4. Basically this applies like the sine transformation, which is similar to over here, which instead it implies the cosine transformation. Then afterwards we plot like the hour sine and the cosine sine over here, and then we title and then we label the x value and the y values, and then we plot it over here. Next we move on to day of the week cyclical encoding. So plt.subplot 1, 2, 3 basically creates the second subplot in the grid. Then we move on to the days is equal to range from 1 to A. Basically creates like the days from like the week, so like from 1 to 7 basically. Then we move on to days sine is equal to np.sign 2 times np pi np array brackets days divided by 3. Basically applies the sine transformation to the days, and then over here we apply the cosine transformation for the days. Then here we plot like the sine curve and then the cosine curve over here, and then we label it. They labeled the graph, then we label the x value and the y value, and then we plot it over here. So here we have the graph for like the hour cyclical encoding and like the day of the week cyclical encoding. Basically, cyclical encoding ensures that like hour like 23 and hour 0 are close to each other, and that Sunday is and Monday are close to each other. This is important because it teaches the machine learning models that time values such as like 11:59 p.m. and 12:01 a.m. are actually close neighbors and not like are like 23 units apart. Basically allowing the model to correctly learn like delay patterns repeats in the cycles and making like predictions much more accurate for flights near time borders over here. So yeah.